I'm a synthetic organic chemist. Origin of life is purely synthetic organic chemistry. There's no way around it. I am perfectly situated to be commenting on this, to be critiquing the origin of life research. It is abiological. It is before biology takes over. This is purely synthetic organic chemistry. And making these compounds is very simple. 4 classes of compounds. You have to make them from what's available on a presumed prebiotic earth. And so the chemistry is not hard for a synthetic organic chemist to follow, and any trained synthetic organic chemist can follow me on this. And I've never seen a synthetic organic chemist disagree with me on this. In fact, the people that might disagree with me are biologists because they've never made anything. The only thing they may have made is they buy a kit and they make it, which is made by chemists, but they've never made anything ab initio. And so it's the synthetic chemist that can critique origin of life research better than anyone else. So go ahead, ask your synthetic chemist friends to listen to what I have to say. If they have anywhere a master's degree or beyond in synthetic organic chemistry, have them critique what I say. We do not know how to build even a simple bacterium. The simplest bacterium with its 256 protein coding genes, we have no idea how to build it. First of all, we don't know how to build the molecules, the 4 classes of molecules that are needed for it. We don't know how to, even if we had those 4 classes of molecules, assemble them even into the simplest of bacteriums. We don't know how to do that. One can do that with the technologies we have today. We can make technologies, but we can't even make the simplest bacterium. Anybody who would say something contrary does not know what they are talking about. Show me the demonstration. Nobody has ever done it. And it's not because of lack of effort. It's not because of lack of will. First of all, they haven't been able to get the molecules to do this. And if they could make the molecules, even if we were to give them the molecules, they wouldn't have the information. There would be no inherent information in the DNA. But even if we gave them the DNA in the structure that they wanted, they wouldn't know how to put all the components together because of the sophistication within a cell. The interactomes, meaning that the interacting connectivity between the molecules, the van der Waals interactions, all of these have to be in the right place and in the right order for a cell to function. We don't even know how to define life, let alone knowing how to spark it to begin. When one looks at a typical textbook, one will see some prehistoric pond and molecules, and those molecules coming together and forming a cell, and those cells coming together and some slithering creature coming out of this pond. That is fallacious. There is no truth in that. We don't even know how to make the molecules. We are lost on how to do this. We can't even make the basic building blocks. But even if we could, from prebiotic type environment to make these, with all the intellect that we put into this, even if we could make them, we have no idea how to assemble them. You say, well, we can make the liposome, the cell membrane. We cannot. There's over 40,000 lipids have been identified in cell membranes. You want to take some simple ones? It's not just individual lipid membranes. You have to have the inside and the outside of the membrane have to be different. You have to have this huge array of proteins, that transmembrane proteins, and you have to have carbohydrates on the surface as identifiers. Even in the simplest bacterium, we have no idea how to put the structure together. It's not there. So not only do we not know how to make the basic components, we do not know how to build the structure even if we were given the basic components. So the Gedanken experiment is this: even if I gave you all the components, even if I gave you all the amino acids, all the protein structures from those amino acids that you wanted, all the lipids in the purity that you wanted, the DNA, the RNA, even in the sequence that you wanted, so I'm even giving you the code. And so now I say, and all the nucleic acids, can you now assemble a cell here in your individual bodies, not in your individual laboratories, not in a prebiotic cesspool, but in your nice laboratory? And the answer is a resounding no. And if anybody claims otherwise, they do not know this area. This is how far the misunderstanding has gone. Even science professors, even biology professors, think that there is a near building of life, that we understand all the ways to build life. We do not. Not only have none of the molecules been made ab initio under prebiotic-like conditions to make the homochiral molecules that are made. Remember, we need 4 classes of molecules. We need the nucleic acids, and then the homochiral systems that for the amino acids, which then need to be built up into protein structures. We need the carbohydrates, which have to be built up into the polycarbohydrate structures. And then we need the lipids, which also are chiral. All of these we need in homochiral form. We don't know how to do this in any prebiotic type scenario at all. These have not been made. And then to assemble these into a cell, it's never been done. So there's a gross misunderstanding. And this misunderstanding has come because of the projections of those who work in the area of origin of life. They do one little thing and then they extrapolate it, and then they work with the press to ramp it up even more, and they project as if they really know it. And so the layperson reads this and says, you see, scientists understand. And then it's not just the layperson. Scientists think that other scientists understand all of this, but they do not. There's a great negative outcome of this beyond just leading the audience, leading the general public astray. What happens ultimately is you end up with 100 million people in the United States that no longer believe this. And then you have the scientific elite saying, why is there 100 million people that don't buy into this? And that distrust will go beyond just that particular topic. It will extend into other topics. And so it yields a distrust of science. Some people argue that since there's been hundreds of millions of years available, the probability that there's the chance that these things could happen in hundreds of millions of years. But that's not true. Time actually can be an enemy when it comes to organic synthesis. Prebiotic synthesis is before biology. So one has to make chemicals. Many of the chemicals that need to be made for life are kinetic products, meaning that they're not the most thermodynamically stable form. For example, carbohydrates, which is the main class of compounds. These are the units that hook together DNA. These are the units that have identifying aspects on cell structure. These are the units that the cell is going to need for the energy of life. Carbohydrates are kinetic products, meaning that if they should form, they would decompose. They decompose over time. And relatively short amounts of time, they decompose. The very reactions that make them, unless somebody is there to pull them out, to fish them out, to stop the process and to put them in a bottle under inert conditions in a freezer. And not just one, there's many, many different types you have to do this. They end up going through a process of what's referred to as caramelization, meaning that they polymerize. They polymerize. The very aldol reactions that were used to make them just continue. And you get polyaldols, you get polycondensation reactions, and they caramelize. Or they undergo, with formaldehyde, which is a presumed prebiotic chemical, they undergo rapid Cannizzaro reactions. So the aldehyde is oxidized to formic acid, and this nice carbohydrate that you made has just been reduced. So the aldehyde from the carbohydrate has gone back to an alcohol. So there's competing reactions. So time does not solve the issue. The other problem is if you had 400 million years to get to a certain point in a synthesis of a particular class of compounds, now you run out of material. Anytime you do synthesis, you run out of material, even when you've optimized yields, and you got to go back to the beginning. Well, say it took you 400 million years to get to a certain point on a synthesis. Now you have to go back and make more. But how do you go back and make more? because nature never kept a laboratory notebook. Never doesn't know how to go back. Never kept a record. So even if it could make more, it doesn't know how to, so it's got to start all over again somehow. But it doesn't know how to start over again, doesn't know why to start over again, because it doesn't know what it's going toward. So if you look at it, people have been trying for a long time. If we just take Miller-Urey as the first example, where Miller and Urey took some basic chemicals that are presumed on a prebiotic earth, hydrogen cyanide, formaldehyde, and CO2, and they put those across a high voltage, simulating lightning, you can get some racemic amino acids out of those. But those racemic amino acids were racemic. Okay, that was in 1952. That was 2/3 of a century ago. What has happened in 2/3 of a century since Miller-Urey in other fields? Well, we've had human space flight. We have satellite connectivity. We have the internet. We have the entire silicon era of microchips, and we have computer technology. We have all of this. In the same 66 years, 2/3 of a century, we are still exactly where Miller and Urey were. We make a barrage of stereo-scrambled chemicals, nowhere close to even knowing how to make them and hook them together. They got to get hooked together in the proper order. We are clueless on this, clueless, because time doesn't solve this. Even with all our ingenuity, time is not going to solve the problem. You let these chemicals that have been made, you let them sit around, even for months, and you can look even in the origin of life researchers themselves. When they've let these go for weeks, they show the degradation of these in a period of weeks. Weeks is the twinkling of an eye when it comes to prebiotic timescales. The chemicals decompose. The environment for the chemicals, environment rich in ammonia, is going to turn carbonyls into imines. These are going to cause further destruction. The ammonia environment itself is quite basic. You're going to have extended aldol reactions coming on. So to think that the molecules could be made and sit there waiting for other molecules to come in, it doesn't happen. Organic chemistry doesn't work that way. Any student that is lazy enough to set up reactions and like to go home for the weekend without working them up pays the price for that, with a depressed yield generally. As soon as the reactions are done, or as soon as what you want is the optimized yield, you have to stop that reaction, get it away from the starting materials, or else what happens is it goes on to polymerized product. Especially when you're making kinetic products, which is not the thermodynamically most stable product, which is exactly what you get in many of the chemicals that are needed for life. So time is actually the enemy. There have been many people that have tried in origin of life research to make the chemical building blocks for life. The vast majority of the chemical building blocks are chiral, which means that they have a non-superimposable mirror image, just like our hands. The left hand and the right hand are non-superimposable mirror images. They're mirror images, but they can't be superimposed, and that's why a left-handed glove doesn't fit on the right hand. The vast majority of biological molecules are handed like that. To make them handed is difficult. We know how to do that in synthetic chemistry. It's never easy. Using prebiotic environment, it's never been successful. Some have said, well, this could happen on a chiral crystal. One can get small enhancements, but not nearly what you need, and it's never been demonstrated, even with all the intellect that people have put behind trying to do this with chiral crystals and chiral layered environments and chiral clay environments. The chemicals that are needed for life are more than just carbon and water. The structures that are needed. One needs the amino acids. The amino acids then have to hook together to form proteins. It's not easy to get amino acids to hook together. One can get very small amounts if you just add a catalyst to it, but the yields are extremely low. There are many activation steps that are needed to get this efficiently. In nature, in biology, once you have life, this is all done with nature's little nanomachines called enzymes. But what we're talking about is prebiotic, long before enzymes themselves are made, and the enzymes themselves are made out of the amino acids and proteins. Then after we have the amino acids, we've got to have the carbohydrates. The carbohydrates are another class of molecules. And then you have to hook the carbohydrates together. The carbohydrate hooking together pattern is extremely complex. Just the carbohydrate, the simple carbohydrate, D-mannose. If you just make 6 units of that D-mannose, that D-mannose can be hooked together in over 1 trillion different combinations, depending on how they're branched and what the constitution is of the primary linkage point. Over 12 trillion combinations, and only one works. Only one will work. How do you get that? Now, you also have to have the lipids. The lipids have to have 2 tails, not 1. If you have the monoacyl lipid, that destabilizes any lipid bilayer. And these also have chiral centers. Again, how is that done in a prebiotic system? Nobody knows. And then you have to have the nucleic acids. So you have to have the nucleobases, and those nucleobases have to somehow hook very cleanly to a carbohydrate that had to independently be made. And then you have your nucleotide that then had, with a phosphate group on there, that then has to hook together. Again, that's only done by enzymes. We don't know how to do that cleanly before there's enzymes. All of those pieces we don't know how to make, let alone hook together. Some might suggest that there are certain laws that we don't yet know, undefined laws, that would dictate the origin of first life. It's very hard to comment on something that we don't know anything about. However, one would have to have law upon law upon law upon law, one after another, to make the requisite molecules needed for life, and then to have those requisite molecules assembled. Because even if one had the molecules, which is very hard to do, how do you do the assembly? We don't know how to do that. Now, if there's some law to do this, remember, just the interactome, just the protein-protein interactions within a single yeast cell, the 3,000 proteins, it's 10 to the 79 billion power on the possible combinations of just the interactome. How do you get those to order? Of course, there is a large cascade of arrays that can get these to order, but that always has life spawning life. We don't dehydrate cells and get them to work together again. Cells will split and pass that information along to other cells. We don't know how to spark these things. And it can't happen from a single unknown law. You'd have to have unknown law upon unknown law upon unknown law. It takes a lot of faith to do that. I'm not sure I have that level of faith, but if they do, good for them. Every year we understand more about the complexity, so we are more befuddled now than we were in 1952, because we found that this is not just a massive protoplasm, highly complex environment. So when a cell wants to move material from point A to point B, it's a factory. You go to a factory, what do you see? You see these overhead carriers carrying machined parts from point A to point B. That's exactly what happens in a cell. You want to carry material from point A to point B, a microtubule will form between point A and point B. And then materials will transfer across that. But then what happens is that microtubule then dissolves and then is reconstructed somewhere else where you need other material transferred between any other 2 points. Why does a cell go through this? Because if it kept all of those microtubules in place, it would become too rigid and it couldn't function, and it would run out of the building blocks to build more microtubules. So it has the ability to morph its structure of its factory on the fly, something we don't even know how to do. The complexity of this is so grand. And the complexity becomes more and greater every day when we start understanding the complexity of the interactome, which is not merely protein-protein. You have protein-DNA interactions, the interactomes between these, the van der Waals interactions between these, the non-covalent bonds, just the way these two interact. And information is passed through these non-covalent interactions. Information is passed through something that physicists call virtual photons. The complexity is so great, and it gets harder every year. So in many ways, we're getting further from understanding origin of life every year once we understand the greater complexity of the cell. So if one wants to use a probability argument to say that there must be billions of inhabitable planets in our universe, or even going with string theory and suggesting that there are multiverses, so there's lots of universes like ours that go beyond even our universe, the numbers are still difficult. So remember, just the protein interactions in a single yeast cell are 10 to the 79 billion combinations. The number of elemental particles in the universe is 10 to the 90. We got 10 to the 90 elemental particles in our universe, let alone planets. Particles in our universe the estimate is 10 to the 90. I'm talking, so that's a 1 with 90 zeros after it. Just the interactome combinations of just protein-protein in a single yeast cell is 10 to the 79 billion. That's a 1, not with 90 zeros, but a 1 with 79 billion zeros after it. These are the types of numbers we're talking about. It's hard to fathom. Then in addition to just those 3,000 proteins that are there in that single yeast cell, you still need all the DNA, all the RNA. You need to have all the carbohydrates. Remember, the carbohydrates have all their own definition order by the way they're hooked up. Remember, just D-mannose, you can put more information in the carbohydrates that are on a cell surface than you store in DNA and RNA combined. And that information has to come from an original DNA template plus a series of other enzyme cascades. All of this is in that cell in addition to those interactomes. It's very complex. Origin of life is a complex problem, and it's hard to throw this at the feet of just large numbers.